All right. So, welcome everyone to part three of our four-part Girls Steam Ahead with NASA series here at South Brunswick Public Library. Before I start, I do want to say this series was made possible by NASA and the National Girls Collaborative Project. So, I want to recognize them and thank them for making all four parts of this series possible. We've had a lot of fun so far. We have one more event next week, Thursday, here at the library at 5 o'clock. The goal of this series has been to educate and inform children of all ages, but specifically young girls, about the wonders of space and astrophysics. SBPL has aimed to inspire girls to pursue careers in STEM fields and to open up pathways for them to learn more about these subjects by providing hands-on activities to do, opportunities to meet female role models such as Sarah, in STEM fields and learn about latest research in astrophysics. I'm happy you're all here, but a special thanks to our speaker for adjusting her schedule to be here with us tonight. I'll introduce you guys to our speaker for the evening. Sara Rosborough is a PhD student at the Rochester Institute of Technology. She is working in the laboratory for multi-wavelength astrophysics. I did stumble on it. I promised I wouldn't. I'm not going to act like I know what that is or what it entails, but I'm excited to find out from Sarah a little more about what she does. She has a bachelor's degree in space physics from Embry-Riddle at Aeronautical University. Man, I triple out on those words. And a master's in astronomy from the University of Sussex in England, which is really cool. And she's worked with at NASA's Goddard Space Flight Center multiple times in the past. So she is a wealth of knowledge and experience and a lot to pull from, and I'm excited to hear more about that tonight and for her to share that with all of you guys. Now, before I pass the baton to Sarah, just a quick note that after her presentation, if you guys have any questions, we'll open the floor to any questions that you'd like to ask Sarah. If you'd like to ask them in person afterwards, that's wonderful. We'll unmute you and you guys can ask them. Otherwise, you guys can go into the chat and post those questions in there as they come up. Sometimes I find that helps me to just write down the questions when I think of them so I don't forget them later. And if you guys put them into the chat, then I'll just keep on collecting them. And when the time comes, we'll just read through them and ask Sarah whatever you guys have to think of. But no one came here to hear me speak. So without further delay, I present Ms. Sara Rosborough.
There we go. All right. Everyone can see that all right? Okay, so yes, so thank you for the introduction. I'll go into my background, expand on all those topics that he had brought up. But first, I wanted to kind of get at what is a scientist, because it might not be what you think it is, actually. These are people who are curious about the world. These are people who continuously ask why and want to know more. And they use something called the scientific method to solve mysteries of the world and the universe. And perhaps you remember the days, or maybe you're still do this, where you ask an adult why, and they give you an answer and you keep going, but why? And perhaps that adult gets annoyed eventually. I know this used to happen to me. And it's sort of a running joke amongst almost all scientists that they are still little kids who are perpetually curious about everything and just want to know more and continuously asking why. So importantly, though, the last point is they share their processes and what they learned with others. It's very much a community, which I will talk about more later on. So here are some qualities of a scientist. They're curious, they're observant, they ask lots of questions, they're imaginative and creative, and they tell stories. And that's actually how they often present their work. When I'm writing up my findings, when I was first learning how to do scientific writing, my advisor told me, you're telling a story. You're telling the story of how you did your process and what your conclusions were. And these qualities are also qualities of artists. So as you'll see, qualities of artists and scientists are actually quite similar. And it used to be, it was STEAM, science, technology, and engineering. And it wasn't until relatively recently they added the A for artist. And I definitely agree with that. There's a lot of overlap between science and the arts, which I will also talk about. But first, I want to talk about some notable women in STEAM that perhaps you've not heard of. So this is Dr. Burnell. When she was a student, a graduate student working on her doctorate, she noticed a strange signal in her data. She was looking at radio waves. And at first she thought it was a mistake, but then she looked again and kept checking her work. And after a lot of testing, she realized she had discovered a brand new type of star called a pulsar. So sadly, at the time, she did not get much credit for this. And in fact, her advisor and his colleagues won the Nobel Prize for the discovery of pulsars. Now that this story has come to light, she has received credit, though probably not as much as she is due. The Nobel Prize is probably the most prestigious award in physics you could receive, which she was snubbed. There was also Dorothy Vaughan. Perhaps you're familiar with the movie Hidden Figures, which featured her. She was a NASA computer. And when I say computer, I mean computer. So way back in the day, doing calculations and computer programming was actually thought to be women's work, if you can believe it. It's not thought that way actually today. It seemed to match up well with what secretaries do. So a lot of women were the ones who were actually doing the calculations for NASA, and she was one of them. And she became the first African-American supervisor at NASA. And she became an expert in computer programming. This computer, actually right behind her, is the one she programmed in a language called Fortran, and she taught her employees that same language. Dr. Ride, she is the first American woman in space. She did this at just 32, which is the youngest American astronaut in space too as well. In 2013, President Obama awarded her the Medal of Freedom. Sadly, she had already passed away in 2012, but her partner accepted the award on her behalf. And Dr. Ocampo, she is so cool. She's amazing. She's originally from Colombia. She is, she was an earth scientist at NASA JPL out in California, and now she's at NASA HQ in Washington, DC. And she led 6 expeditions to areas off the coast of the Gulf of Mexico and discovered a huge crater. I encourage you to go look up the images online. That is most probably left by the asteroid that killed the dinosaurs, which is so amazing to me. Yeah, really cool lady. Okay, so enough about them though. Now for me and my path. So when I was your age, I also asked a lot of questions, which I imagine you guys do, because we are all born with a natural curiosity for the world. Kids are supposed to ask questions. That's how you learn. So I often annoyed adults with my incessant questions, but that's good. Scientists, that's their whole thing. They ask lots of questions. But eventually I would get to the point where the adult would be like, I don't know, you know, so I would have to go to a book and find the answers for myself, or observe the world around me and try to figure out the answers for myself. So I had stumbled upon an astronomy book that told me about the constellations. And the constellations are a group of stars in the sky that form pictures. So I had trouble sleeping as a kid. And I also grew up in a country town. So there were not a lot of city lights, which that means I could see the night sky very well, lots of stars. And I was determined to find the constellation, the Big Dipper, which maybe you have heard of. It looks just like this. This is the Big Dipper. It looks kind of like a spoon. So I tried very hard night after night with my book and a flashlight, probably keeping my sister awake, to find the Big Dipper. It was very hard, and I was struggling with it because I was looking for a region in the sky that was maybe like this big. And then I finally realized that the Big Dipper was much bigger than I realized. It was taking up a huge portion of the sky. And I think that's when I realized space is really big. It's really big. And that just blew my mind. And ever since then, I've been very interested in astronomy. So I did different science programs throughout middle school and high school, which I will give you the QR codes to a little later on. But I'm going to fast forward to college. Oh, excuse my cat. I went to Embry-Riddle Aeronautical University, that's in Florida. I studied space physics. And at the time, that university was 85% guys, which might sound wild because it is. There was hardly anyone there who wasn't doing a technical major because it's an aeronautical university. So very few females. There were sometimes classes where I was the only female, which was a struggle. But I stuck with it. And this was some time ago now. So these percentages are getting better. Institutions across the US are recognizing the need for diversity. So I doubt that statistic is severe as it is today, then as it was today. I did make friends with someone who is African-American, and he also felt some prejudices. So we made a pact that if we found a professor who was looking for students to help him with astronomy research, we would tell the other one. And that's exactly what happened. So he found a professor who was studying the moon and told me about him. And I asked that professor if I could work for him, and he said yes. So I started studying the moon, specifically the atmosphere of the moon, which the atmosphere of the moon is extremely thin. It's almost non-existent. But through that work, I was introduced to a scientist at NASA. And that's what led to my internships at NASA. So I did 2 internships there. And then after I got my master's in astronomy, since he liked my work as an intern, I got a job as a contractor at NASA, where I worked for 2 years. So during my time at NASA, I was there for the 60th anniversary, which was really exciting because we took this photo. So this was taken at NASA Goddard. I don't know if this is all the employees at NASA, but it's certainly a lot of them. They all directed us into this to form this 60, and someone had a drone and they flew over us to take this picture. So I continued to work on the lunar exosphere there. However, I actually wanted to learn about other topics in astronomy. So I went around to other scientists and were like, hey, tell me about what you do. Which scientists love to talk about what they do. So everyone was very welcoming, and they actually invited me into their group meetings. And so I got to sit in and listen and learn about what everyone else was doing. And I decided to leave to continue my education to get my PhD, which is what I'm doing now. And because I had learned about all these other different research topics, I'm no longer working on the moon. I'm working on something totally different, actually. So here's another image of the 60. So lucky for me, my friend who I went to take this photo with was wearing a bright yellow skirt. So I always know where I'm standing because I can see my friend's bright yellow skirt. She's right there. And then I'm right next to her in that blue shirt. And then my other friend is on the other side of me. I'm so glad she wore that bright yellow skirt, or I would never have found myself again. So now I'm a PhD student, working on my doctorate. And after I finish, I hope I'll be able to go back to NASA. I've kept up some of my contacts there, so we'll see. So I now study the centers of galaxies that are rapidly growing, and they're growing so fast, we call them active. And since they're at the center of the galaxy, they're called active galactic nuclei. So they're pretty impressive objects. Here's an image of an active galactic nuclei, or an AGN. Lots of high energy coming out here in the form of jets. And this is a multi-wavelength image, which Matt had mentioned at the beginning. So multi-wavelength means there are different kinds of light, which perhaps you're surprised to know that you actually already know these different kinds of light. There is UV light. That's the light that gives you a sunburn. Microwave, like your microwave in your kitchen, that's a type of light. Radio, that's another type of light. X-rays, if you've ever been to the doctor and gotten an X-ray, that's another type of light. And then there's also visible light, so that allows you to see. So all these different kinds of light will tell you different information about an object. And if you compile that all together, you can make images like these. So as I had said at my undergraduate university, Embry-Riddle, it was 85% boys. But now at RIT, my advisor is the program coordinator, and he has worked really hard on diversity. And it is just about 50% female and 50% male. So that is pretty impressive, and he's quite proud of that ratio, as he should be. So now I'm going to talk to you about some of the programs that I did and some that I wish I had done and ones that you can do. So there's the Sally Ride camps. They have changed a lot. I did this when I was in, I believe, 7th grade. It was a summer 1-week program. It was just me and one other girl, so it was quite small, and we made craters. It was so much fun. Basically, we played with mud, and then we dropped rocks from a really high point and made giant holes in the mud. It was very messy and it was wonderful. But now they have a whole bunch of different programs, a whole bunch of different space camps. And now they have a cyber camp and a robotics camp and a family camp. So you can actually go with your parents if you want. And I think they also have stuff now that's even just for adults if your parents are interested. So here's a QR code that'll take you to that website. I'll show those QR codes at the end as well if you don't catch them right here. Another one is the Center for the Talented Youth. This is run by Johns Hopkins. However, you don't necessarily have to go to Johns Hopkins University. They have locations or sites all over the country that you could go to. But Johns Hopkins might be actually the closest for you guys, maybe, I don't know. There might be one closer. So these are educational summer programs from grades 2 to 12. So that's a pretty large range. They have a lot of different topics, They could be online and in person, which is also new. They're not free, but they do have funding options and scholarship options, and you will need to take a test, but don't let that deter you, because if you don't try, then, well, you're guaranteed not to get accepted. But if you do try, you might get accepted. There's also Girls Who Code. I love Girls Who Code. I wish I had done this when I was younger. I was quite nervous about learning how to code. I thought I didn't need to know computer programming. It turns out I did need to know computer programming. It also seemed very intimidating to me when I was in high school. And it took me a long time to learn, but now I actually do really enjoy coding. You guys might be more adept to coding than I was, though, in the technology age that you all live in compared to when I was your age. So Girls Who Code have summer programs, which this QR code will take you to the summer programs, but their website also has a ton of other cool stuff you can do. They had one where you could program like your own music video, I think, or you could edit the music video. And this one is you can design your own avatar. So here's a little snippet of the code where you can edit parts of the code to change the character how you like and her background. And they'll take at any level of coding. So if you're brand new to coding, they'll walk you through it step by step. So it's very good for beginners. Okay. Oop. Next slide. There we go. All right. Zooniverse. Zooniverse is pretty fun. If you want to work with real science data, you could do that right now. Scientists need a lot of help. And so they have these programs called citizen science, where they actually give the public their data and say, here's what we need help with. Can you please help us? It's usually when they have a lot of data that they need to deal with. So if you go to this QR code, it will take you to the Zooniverse webpage, and there's a ton of different topics you can choose from across a bunch of different fields in science, and not just science too. So I'm going to give a shout out to the Redshift Wrangler, which was made by a group of my friends. So in Redshift Wrangler, you look at data of galaxies and you try to figure out how far away they are. There's also a very good one by NASA. It's called the Jovian Vortex Hunter. So this is a picture of Jupiter taken by the Juno mission. And if you'll notice, there's all these swirls and vortexes going on in the clouds. And in this project, they want to map all of those swirls. And that's a lot of swirls. And that's why they need help. So if you choose this mission, then you will look at all of their images they have and draw circles or boxes around all the vortexes you can find. This one's quite fun because you get to look at a lot of really pretty pictures. Okay, so NASA has a ton of learning resources on their websites, so I don't have time to go through all of them, but two in particular I want to give a shout out to is Interplanetary on YouTube. This is made by a friend of mine, James. He's very chill, very good planetary scientist. His videos are really pretty, really fun. They're all about the solar system. Here's an example of one of his videos that's showing all the different planets rotating along their spin axes. And another one is APOD. which stands for Astronomy Picture of the Day. This was also started by a guy at NASA. I think he just started it for fun because he realized a lot of photographers had these beautiful pictures of space or the night sky. So every day on this website is a new picture of astronomy, and it's open to the public. So you could submit a picture to APOD. If you have a gorgeous picture of the night sky or anything astronomy related, you can send it to his email. It's on the website. And if it gets selected, then he will put it up as the astronomy picture of the day. They also give a little paragraph blurb explaining what the picture is about. So this picture here is a nebula. It looks like a bubble because it is. This is a bubble of gas that is expanding. That was taken by the Hubble, I believe, the Hubble telescope. Okay. Now, as I've been kind of hinting at, what with the the artists and the citizen science work is that scientists do not work alone. NASA partners with so many people around the globe, not just other scientists, but graphic designers, animators, writers, producers, photographers, and even lawyers. This is actually a growing field, is space law. So if you were interested in becoming a lawyer, but you also really like space, you could be a space lawyer. There is a whole department at NASA where the graphic designers reside. It was my favorite department to visit because their hallways were gorgeous, all decorated with these beautiful images. And the scientists work with them pretty closely for a lot of different reasons, actually. So one, they would help us when we need anything visual being set up, such as presentations like these. But perhaps more importantly, they would help us with outreach or advertisements like this. This is advertising an X-ray telescope called NuSTAR. Also for diagrams, if we need to explain something, but we don't actually have an image for it, they would go to the art department, and scientists would work with artists to develop diagrams like this to explain the sun. This is what the inside of the sun looks like, according to an artist and a scientist who work together. And then there's some things that we have no idea what they look like. We've never taken a picture of them because maybe it's just too far away. So a scientist would then go to an artist for help. They would kind of describe what it would look like, and the artist would give their interpretation. So here is actually an artist's interpretation of what I study, an active galactic nuclei, because we actually haven't had too many very good pictures of those. So we often have to go to artists and say, hey, can you draw this for us? Because we don't have any pictures. So NASA has art programs, actually. So that could be promotional work, such as this drawing here. They also have an art gallery that a previous scientist named James Webb put together in, I believe, the 50s and 60s. So these two QR codes go to two different NASA art links and art opportunities if you're interested. I believe one of them is even a contest, and they separate them out by grades. This year's contest, I think, has already passed, but if you wanted to do next year's art contest, follow that link and it'll give you the information. Another thing is science writing. This is extremely important because you are communicating your science to the public. And scientists do their own writing, but it can be very technical and it can be difficult to communicate that to the general public. So at NASA, there are writers and journalists who have offices, often right next to the scientists, and they work with the scientists, they interview them. Sometimes they actually go with them to different sites to see what they're doing and follow along on their process so that they can then write about it and report it to the general public. They'll also work with the artists or photographers and sometimes even the press. So here's an example of a science writer at NASA, Catherine. She actually went with the scientists to the Arctic to get this photo and to write about their work. So these are two NASA scientists in the Arctic. They're measuring the ice, the level of the thickness of the ice. And she is flying above them in a helicopter and took this image for her article. Okay, so the future of NASA. NASA is a part of the government, and the government is for you. So NASA is for you and it is by you. And NASA is working on missions with you in mind because you are the future. So future goals are going back to the moon. The Artemis mission is happening currently. It started last year. And it will land the first woman and first person of color on the moon. Their goal is next year, 2024, but these things often get delayed. So I would take that with a grain of salt. And their goal is to actually build a lunar base. Here's the crew. They've already been selected. So this is going to be happening very soon, back to the moon. And back to the moon to build a lunar base, and that lunar base will serve as a gateway to Mars. So this having humans on Mars is very likely to be in your lifetime. There's also the next generation of telescopes, a fleet of telescopes, 4 telescopes. They're all going to look at different types of light. So there's the habitable worlds, which is going to look in the infrared and visible light or optical and the UV. That one's coming first. And then after that will be Origins and LUVAR and Lynx. So these 4 like pizza slices here are representing each of the 4 different telescopes. And this isn't going to be happening until the 2050s. So in 30 years. Now, I'm 29. In 30 years, I'm going to be almost 60 years old. But in 30 years for you, how old are you going to be? Probably my age, maybe a little older. So these telescopes are really for you. The people who are currently building them are in their 50s. So in 30 years, they're going to be in their 80s. They're probably going to be retired. So NASA really wants young people to be involved because they are doing all these missions with young people in mind. Here's a video of LUVAR, which is my favorite of the fleet. I think it's really beautiful telescope. Okay, so in conclusion, anyone can be a scientist. We are born with a natural curiosity. You just have to feed your curious nature. Ask lots of questions, even if you annoy people. And if you annoy people, you'll have to go find the answers for yourself. You don't have to be a scientist to be a part of science. Scientists work with writers and with artists and with lawyers, the press, a whole host of others. NASA is continuously planning and building missions with you in mind. These are for you. So they want you to participate and they want to involve you. In my experience, NASA has the most outreach programs I have ever seen. So here are all those QR codes, again, in case you didn't get them at the beginning. And that's all. I'm happy to take questions now.
That was awesome. Sarah, thank you so much. We actually did get a few questions in chat, but I didn't know if anybody wanted to ask any questions in person. I'll give you a second. If you do, you can just raise a hand and you can ask your question. Otherwise, I'll field the questions. I've actually got some questions of my own as you're going along, and I'm just like typing away. I'm like, all right, I can ask that. I know Alice, you had a couple questions you put in chat. I
Mm.
appreciate that. The first one was Alice said she saw something named Ceres on your screen,
Oh,
Ceres, and she was wondering what that is.
Ceres. That is a dwarf planet. So Pluto is also a dwarf planet. And there actually are a lot of dwarf planets in our solar system. Ceres is not the only one. So what constitutes a dwarf planet is that they have enough gravity to be spherical, but they're not quite massive enough to have, say, like their own moon orbiting them. So they used to think Pluto has a moon, but it doesn't really have a moon. Its partner is Charon or Charon. And they're orbiting each other like this. It's not like one orbiting the other.
I'm gonna ask another question because that just came up in the chat. Also, as an older man, child of the '80s, I'm still fighting the good fight for Pluto, but that's just me. Um, so we have a question that says Elon Musk said he will find a way to make people live on Mars by 2024. Is
Wow.
that going to happen?
No,
That's
that's not
next year. No, okay.
Yeah, I don't think that's gonna happen. That's
Which is
Elon Musk. He
so just
often makes
don't
a
book
lot
my
of
ticket.
he makes a lot of promises, but SpaceX works with NASA quite a lot. So SpaceX launches from NASA's pads. They rent them out from NASA. So they do work closely together. But no, I feel like he needs to do a lot more
Probably not.
than
Yeah,
uh,
wouldn't book your tickets right now.
yeah.
Alice sent a question earlier asking what exactly is in the middle of an active galactic nucleus.
A supermassive black hole. I don't know if you've ever heard of a black hole, but
I mean, I
they're
have. I'm assuming you have too.
they're very mysterious objects, which is one reason why I'm quite interested in them. So our own galaxy has a supermassive black hole, but it's not active, and it's called Sagittarius A star. They took a picture of it not too long ago, actually.
Huh.
Mhm.
Alice just sent another question asking if all these planets spin in the same direction.
They don't. Yeah, they all have
Oh,
so
they actually spin. There they go.
yeah, they're all spinning in different directions, and there are people who are trying to figure out why that is. So this Uranus, for example, is really wonky. It's on its
Yeah,
sides.
right.
So one idea is that maybe it got hit during formation. Maybe a moon came by and hit it and knocked it on its side.
Huh. Oh, another question coming through. Man, they're coming hot and heavy now. Alice is asking, is there such a thing as a white hole if there is a black hole?
Oh, wow. Good question. My goodness.
Right?
That's advanced general relativity. Oh my goodness. That's graduate school level question. Wow. Nobody knows. Some people think so. I don't know if you've ever heard of Roger Penrose, but he was a friend of Stephen Hawking. So he came up with this diagram called the Penrose diagram, that showed a black hole, kind of like a funnel coming down, and then another funnel that sort of opened up at the bottom that was maybe a white hole. So some people are thinking, oh, is the white hole the opposite, where instead of pulling stuff in, it's spewing stuff out into another universe? Nobody knows.
Alice, you're blowing my mind over here with your questions. That was phenomenal. Two things I want to say real quick, give other people a chance to bring questions in if they have them. first and foremost, I just want to say I love that so much of your journey was advanced, and every next step seemed to be pursuant on you asking questions of those
Mm,
around you. Like, well, what are you doing with this? How do I get into that? And it was just very, you were curious, and that was your nature as a child, and that kind of continued as you went on. I thought that was really cool because it opened a lot of doors for
mm,
you just asking questions, and seeking opportunities. And that's something that you guys um, now and going forward can do as well. I think that's really important.
mhm.
Let me see. Another question just came through. What is an asteroid belt made of?
Well, so the asteroid belt is well made of asteroids, as you probably have guessed, but an asteroid itself is mostly made of iron, and other kinds of rocks.
Huh?
A lot of them have hit Earth. So when an asteroid is coming in through the atmosphere, it's called a meteor. And then when it hits Earth, it's called a meteorite. So they are made out of very similar material that the Earth is made out of. So early on in Earth's formation, it got hit by quite a lot of asteroids. So very similar to the stuff that Earth's made out of, actually.
I've been sitting here for too long. Let me just stand up
Oh, sure.
and make the light turn back on. I can get my stand goal for the hour too. Question for me, actually. You said you grew up in a town with very few city lights, in like the countryside.
Mm,
I just spent some time in the mountains in North Carolina, so I totally understand what you're saying with that, the
mm,
the light pollution and how much more you can see
yeah.
in like an area with none of that, no, lights in the buildings, things like that. Are there any good places you could recommend for kids and for their families to go stargazing?
Ooh.
I know it might be a tough
Actually,
question.
well, a lot of places where you would go camping or hiking are really
Okay.
good for sky gazing. Yeah, there is a program called the Dark Skies. I think it's kind of all over the US. I know they had one in Florida. It was hard to get away from light in Florida though.
Yeah,
So it's probably gonna vary based on the state you're in. But those programs are also trying to encourage cities to turn off their lights for like a day. I don't
okay.
think it's been very successful.
It's tough.
So yeah, I think your best bet is to try to go to a place where you would maybe go for a hike or for camping, away
I like
from
that.
any city, really.
Right. Alice also asks, why is a shooting star called a shooting star if it is actually a meteor?
Yeah, yeah. It's a misnomer. Early on, people didn't know what it was, and it was a bright object that was falling out of the sky. And for bright objects in the sky, we were calling them stars for the longest time. So no one ever thought of a giant rock floating around out in space could be falling towards them.
And once you name something, it kind of sticks. That seems to be how it is. We're
Yeah.
we're stubborn. We're stubborn creatures. I'm going to ask a question real quick, just because it was curious to me. You mentioned James Webb as I believe you said a former artist working with NASA.
Mm.
Is that how you put it? Is that, I'm assuming it's not the same James Webb as the space telescope?
The space telescope was named after him. Yeah.
Okay, I was curious about that. That's neat. I did not
Yeah.
know that.
He was really into art, and he thought it had a lot of power to communicate with the general public. So he commissioned people to, draw art about space and send it to me, and he gathered it and made almost like a gallery.
That's
Um,
awesome.
yeah.
One more question from Alice. How much distance was the closest black hole to Earth?
Ooh. That I don't know. There's different kinds of black holes. There's black holes that have the same mass as our sun. And so they're called stellar mass black holes. And so they're a lot smaller and they're scattered throughout galaxies. So there could be a stellar mass black hole, um, not too far away. It's definitely far enough away that we don't have to worry about it.
We're good, is what
Yeah,
you're saying. Okay,
yeah.
good.
But the nearest supermassive black hole is the one at the center of our galaxy. Each galaxy only has one supermassive black hole, usually.
All right, I'm gonna take one more question from Alice, I believe it is. Yes, one more question from Alice, and then I have a final question to close this out.
Mhm.
Alice's question is, how is it possible to see a black hole if the universe is dark too?
Yeah, so you don't actually see the black hole. That's right. What you see is stuff around it that's falling into the black hole, and it's getting ripped apart and it's getting extremely hot. So it's glowing. So you kind of see like a ring, and we call that the accretion disk. So for a black hole that's active and it's eating a lot of stuff, you get a really big accretion disk and it's really, really bright. If it's not eating that much stuff, then it'll just have a really thin, weakly glowing ring around it.
That's terrifying. So I'm happy to close on one more question, because we met somebody earlier that seemed to be kind of stealing the show, but maybe even the real star of the show. No offense. Your cat. What is your cat's
Oh,
name?
Io. She's named after a moon around Jupiter.
That's awesome. I love that. Well,
Yeah.
Sarah, thank you so much for joining us today, and to the kids who joined us today, and anybody watching at home. We appreciate being you guys being here. Be sure to check out Sarah's QR codes throughout the presentation, and join us next week for our final Girls Steam Ahead with NASA presentation. Sarah, you are incredible. Please continue doing amazing things, and you kids keep on asking questions. Us grown-ups are never too annoyed by them to answer them. We love them. But thank you so much, Sarah, for coming today, and thank you everybody.
Thank you so much for having me.
Take care, guys.
Bye.